Let's look at our next optimization problem. So I'm going to ask which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. So you might want to graph this function, y equals 4 minus x squared. It's a parabola and it points downwards. Right. So we get a parabola, it looks like that. And I want to know which points on this curve are closest to the point 0, 2. So that point right there. So I don't know which point is closest. I'm going to just label it. It's an arbitrary point. Call it xy. And what I want to find is the distance from the point xy to the point 0, 2. So to find that, we're going to use our distance formula. The distance, it's the square root, and then you subtract the x's, x minus 0 squared, plus, and then subtract the y's. So that's the function we need to minimize here. So we want to minimize that function. D equals the square root, and it's x squared plus y minus 2 squared. But we have, what's our constraint here? Our constraint is that x and y it's not an arbitrary point, it's a point on this parabola. So in particular, y has to be 4 minus x squared. So I can use my constraint and plug it in into my function I'm trying to minimize, and then I will have a single variable there. So we're trying to, again, we want to minimize the function d equals the square root of x squared plus 4 minus x squared minus 2 squared. So x squared plus 2 minus x squared squared. And if you FOIL this thing out right here, if you FOIL that out, you're going to get d equals x to the 4th. And then if you combine, you'll get a minus 3x squared plus 4. So this is what we're trying to minimize here. But really, because the square root is an increasing function, we just need to minimize the stuff underneath the square root. So I'll say minimizing d is the same thing as minimizing what's inside of the square root, x to the 4th minus 3x squared plus 4. Now we do this because it's easier to take the derivative of this function f here versus this function d. Okay, and what is the domain here for this function? Well, remember I'm taking a point on my curve, so if I look back here, x could be from negative infinity to infinity, so that's going to be my domain of this function, the domain of f. And now let's find our critical numbers. Take the derivative. So f prime of x will be 4x cubed minus 6x. That's a polynomial. It's always defined, so I just need to set it equal to 0. Factor out a 2x. So I get two solutions. I get from this, I get x equals 0. And then from this one, we're going to get 2x squared equals 3. X squared equals 3 halves. X equals plus or minus the square root of 3 over 2. So now, what are we going to do? We're going to use the first derivative test. So you're going to put your critical numbers on here. Pick some test numbers. So pick -2, -1, 1, 2, and plug them into your derivative. What was our derivative again? It was 4x cubed minus 6x. So if I plug in 1, that will be -2. It'll be positive. -1 will be positive. -2 will be negative. So what does the first derivative test tell me is happening? My function is decreasing and then increasing. This is a relative min. It's increasing to decreasing, a relative max. And here, decreasing to increasing, a relative min. Now remember, we're trying to minimize here. So now what we need to do is look back at these two possible minimums here, right here and right here, and go back to our function that we were trying to minimize, d. And if you notice, all the powers of x are even here, so plugging in these two numbers will give you the same value for d. So what that means is that x square root of 3 over 2, and if x is negative square root of 3 over 2, they give the minimum distance. So if we look back at our picture here, you'll see that there are actually two places that were closest to this point. One on the left and one on the right. And to actually get the point, you have to plug these back into your function. What was our function? Y equals, it was 4 minus x squared. So I'm getting 5 halves. So the 2 points that are the closest points are square root of 3 over 2, 5 halves, and negative square root 3 over 2, 5 halves. So these are the 2 points that are closest to that point, 0, 2.